Part of cognition is understanding how we think. It's not just memory or recall or recognition, but actually being able to process information in our brains and possibly create new information. So you can see 5 bullet points listed here: problem solving, creativity, making decisions, forming judgments, and metacognition. Problem solving is what you're going to practice when you do head games and other cognition problems, and that is actually not just taking a vocabulary word and memorizing a definition, but being able to look at a situation, a problem, whether it's in math class or economics class or a logic puzzle, or maybe how to fix the plumbing in your house or what to do about your computer when it stalls out, but figuring out a personal, unique solution or applying rules of problem solving that you've been taught. So that's part of what we mean by cognition as well. Creativity is, of course, a specific kind of problem solving, and we will do something called the unusual uses test in class next week. But creativity is divergent thinking, thinking of new ways to do things. So it has nothing whatsoever to do with simply applying solutions you've already been told. It's not like being told, if X then Y, X happened, what's the answer? It's more like being told, X happened, what do you think happened? And really having a very open-ended situation or problem to solve. So creativity plays a large part, obviously, in creative writing, in entrepreneurship, in all types of business situations, and artistic, writing poetry, writing drama, all those things involve creativity. Decision making is being able to process information, pros and cons, costs and benefits, and being able to work out, what should I study first, or what's the best way to get to the mall, or whatever kind of decision you need to choose. Forming judgments involves more of an evaluation component. And then metacognition is actually thinking about thinking. So understanding how you think and maybe trying to figure out ways to improve how you think, possibly learning new problem solving skills, possibly learning new memorization tricks. Now we'll move on to the next slide. When our brains process information or concepts or algorithms, problem solving skills, we tend to organize things in terms of concepts, categories, hierarchies, and schemas. And most of them are pretty familiar terms, but probably not schema. So I'm going to go through 3 of them quickly, and then we'll talk about schema for a second. So home is a concept. It's not a specific kind of home. So if you look at the pictures on the right here, we have some different kinds of homes. All of those could be considered home. Home is not the same as house, right? House is a specific item, it's something you can point to, but home is more conceptual. So one thing we do is we tend to assign things to concepts: home, friendship, those kinds of things. And then categories are how we organize. So a hierarchy would involve categories. So you might have a hierarchy where you have home, and then under the category, the concept of home, you might have categories like permanent home, temporary home. You might subdivide into homes that you own versus homes that you rent, or you might put the categories you use might be homes that are built on land versus homes that have wheels and are mobile. So there's a lot of different categories, and the hierarchy would be from the concept into categories and then subcategories. So let's say we decided to make our first subcategories mobile homes versus permanent homes. Then under permanent homes, we could have subcategories of rental homes versus owned homes. So that's how our brains organize information, and that's what makes it a lot easier for us to retrieve the information, because when we're trying to think of the word, rental home, then it would be in this entire concept and category scheme. Schema is a little bit more difficult, and we'll talk about this more in the developmental psychology unit, but we develop schema to help us organize information. So the example that I use is, if you take a small child, a 2-year-old say, and you show them a dog and you tell them it's a dog, then they start to understand what the concept of dog is. Let's say you show them a terrier, and then the next thing they see is a poodle, they might be a little confused. Is that a dog? And you say, well, yeah, that's another kind of dog. So suddenly they start to recognize that, golden retriever is a dog and a yellow lab is a dog. But then you show them a horse or a goat and they think, well, that's a dog too. And then you have to teach them to discriminate. Another use for the word discriminate: distinguish between different types of animals, what is a dog and what isn't a dog. And then they develop the schema for four-legged mammal, and they start to understand that four-legged mammals can be divided into dogs and horses and goats and zebras. So your schema developed as a way of helping you organize the information and build your hierarchies and categories. Another way that our brains organize information is through what we call prototypes. So one way to test what your idea of a prototype is to write down the first example of each of these that comes to mind, which you're welcome to pause and do. But when you hear the word bird, what do you picture? I picture a robin. Maybe you picture a cardinal or a bluebird or some other type of bird. When you say triangle, I would picture an equilateral triangle that looks like the musical instrument triangle. Somebody else might picture a right triangle. So everybody has a prototype in their mind that helps them understand what's going to fit into the organizational categories in your mind that go with that particular concept. When we talk about problem solving, we can talk about all kinds of cognition problems like the head games problems, word problems, shape problems. This is a particular one that I like to do in class, and of course we're not in class, so it's harder to do, but this is one of those little challenging cognition problems that you can test with actually relatively young children to see how sophisticated their cognition is, because it doesn't require any words. They just need to figure out, how can I move the tower from the left peg to the right peg, moving only one disc at a time and never putting a larger one on top of a smaller one. So just for example, and you can do this on your own, right? We can move this once. We can't move this one over here because we can't put a large one on a smaller one. So we have to move this one again, right? And then we can move this one over. So I'll let you kind of figure it out from there if you want to draw it on paper and solve that one on your own. These strategies for solving problems are some of the strategies that you might want to refer to when you're doing the head games problems. So trial and error is pretty obvious, right? When you're doing trial and error, you're just trying out a bunch of things. So if you think about that one problem that has the word, I believe the word is fist, and then you have to change it into a different word, only replacing one letter at a time, you could try a whole lot of different ways to do that, right? You could just go trial and error and try it out with a bunch of different things. You could turn it into fast, or you could turn it into list, and you can just follow them out and see what happens. Might not be the most efficient method, but it is one strategy for solving problems. Algorithms are where you actually come up with an actual strategy. So when you're solving, for example, an algebra problem, it really wouldn't make sense to use trial and error because you know certain mathematical rules that you can apply, and it helps you solve it much more quickly. For example, when I was retiling my bathroom shower earlier this year, and I knew the total square footage of the shower, I knew that I wanted a third of it to be white and 2/3 to be blue. I could just go with trial and error and just buy a whole lot of tile and just put in white tile till I'm done with that part and then put in blue. But it's a lot easier to solve that with an algorithm and to say, 1/3 white plus 2/3 blue has to equal the total sum, and then I can calculate it. It's much more efficient. Heuristics we're going to talk about on the next slide. So I'll hold on to that one for a second. And then insight is basically just arriving at the solution to a problem. So maybe you're really trying to figure out that Tower of Hanoi problem and you're puzzling over it in your mind, then you just let go of it and you go for a walk, and all of a sudden the solution just pops into your mind. And we've seen that there's actually insight learning even with apes. We know people do it, but we've also seen we're not the only primates that are able to learn by insight. And our last slide here is on heuristics. And this is probably a word that you're not familiar with. So heuristics are mental shortcuts. And these are two heuristics. These are not all of the heuristics that exist. There are other ones out there. We may come across other ones in the class. But these are the two that I really want to stress for you to know right now. The representativeness heuristic is basically stereotyping. So we categorize a situation or a person or something that happens based on our experiences in the past. So if, for example, somebody brings over a child to my house, a 2-year-old child, and that child grabs my dog's collar. And then another friend brings over a 2-year-old and I say, I know that kid is just going to grab my dog. I need to, talk to that parent, take preventive steps, right? I'm just saying, I know what's going to happen because I know how 2-year-olds act. And so obviously that kind of heuristic can lead to racism. It can lead to gender discrimination. Oh, I know women don't do very well at this, or I know men are bad at that. And that's a shortcut that our brains use. It has very bad results, but the heuristic itself isn't bad. It makes us more efficient because if we've seen a situation before, I know that every time I come to an intersection like that, I need to slow down because I've had a bad experience in seeing people run a red light, right? Well, that's good if you can use a representativeness heuristic to be helpful. So the heuristic itself is not good or bad, but it can have a negative impact because it can cause us to form stereotypes. The availability heuristic similarly can flaw our judgment because what we're doing with the availability heuristic is basing judgments or evaluations on the information that's most available to us. So if you look at the table over here, this is the risk of death from different types of incidents. And you can see that the risk of death from auto accident is quite a bit higher than the risk of death from homicide or terrorist attack. And yet the things that we fear are, being murdered or being, on a plane, right, that gets taken down. So we fear the things that we hear about in the news. We don't fear the things that we don't hear about. So the things that are most dangerous to us are frequently not the things that we think about, because we're just basing our information on our decision making on the information that's close at hand. Well, I just heard about this. I just heard that happen. So those are two mental shortcuts that we use that save us a lot of time in terms of processing information, but can also lead us to make misjudgments. And that is the end of the notes for this week. So make sure that you use that information about decision making and cognition when you are working on the mind games and other assignments.